The washer method is an effective way to find the volume of a revolved solid. If we're spinning a two-dimensional section around an axis, where the section does not touch that axis along its length. So we'll give the outer circle of the washer some radius, which is going to be defined by the function of this upper curve. So therefore the outer circle of the washer has the following area. And the radius of the inner circle of the washer is going to be described by this curve. So therefore we subtract the area of that hollow circle. And then giving the washer a thickness in the horizontal direction, we obtain the volume of the washer, and then we integrate from x equals a to b to get the volume of the solid. And I encourage you to try this method on this case, where the region is revolved around the y-axis instead. Let's find the volume of the solid found by revolving the region bounded by the parabola y equals 1 and the y-axis, so this 2D region around the horizontal axis. So in this case the curve does not touch the axis, so we can use washers. So the area of the outer washer, which can be visualized in the YZ plane, is pi by the radius squared, and then minus the area of the inner washer, which is pi multiplied by y squared. And we assign the washer a thickness in the x direction of dx, which gives the volume of that washer, and then we integrate from x equals 0 to x equals 1 according to this equation. And that gives the volume of the solid. And now you can substitute for y and evaluate the integral and post your answer in the comments. Let's find the volume of the solid formed by revolving a region bounded by the parabola x equals 1 and the x-axis. So this 2D region revolved around the y-axis. And because that curve is not touching the axis of revolution, we can use washers. So the outer washer has a radius of 1, so the area is pi by 1 squared, and then minus the area of the inner washer, which has a radius of x, and we assign the washer a thickness in the y direction of dy, which gives the volume of the washer, and then we integrate from y equals 0 to y equals 1 according to this equation. And that gives the volume of the solid. So substitute for x squared, evaluate this integral and post your answer in the comments. Find the volume of the resulting solid when this region is revolved around the y-axis. And we're asked to use washers and the volume of a known solid. So the area of this washer is pi by the outer radius squared. So that will be this x value over here, which is y plus 2. Then minus the area of the inner washer, which is this x value over here. So that will be y squared all squared. And then we give the washer a thickness in the vertical direction of dy, and then we integrate from y equals 0 to this y value over here. So we can see that these curves intersect at x equals 4. So when x equals 4, y equals 2. And that gives the volume of the upper solid. And we need to add the volume of the lower cone to get the volume of the entire solid. So the cone has a volume of 1/3 by pi by the radius of the cone squared, and then multiply by the height of the cone, which is 2. And you could have obtained these values from the y-intercept and the x-intercept of this linear equation. And now you can evaluate the integral and post your answer in the comments.